Hey guys, welcome back, and today's video is to walk you guys through Chalk in the Walk. So this is to walk you through the procedures for the distance learning lab, and then I'm gonna swing it over to you, and you guys are hopefully gonna go outside and get a good walk in while you explore the size of our solar system. Okay, so as I said in a video before this lab is not intended to show the relative size of the planets. I have done that along with this before. However, because of the limitedness of materials maybe in people's homes, I just don't feel like that's the best course of action right now. I'll have some other things to show you guys the relative size of the planets. There's some good resources out there and illustrations, videos. There are other ways that we can look at it that are very, very accurate. So really the purpose of this is to use and introduce you all to astronomical units. Astronomical units, or AU, are the way that we measure distance in specifically our solar system. We do not use astronomical units for the entire galaxy. We would not use it for the universe. We would use other units of measurement for that, like light years. But for our own solar system, we can go ahead and use astronomical units, which we have determined astronomical units based on our own planet's diameter. So we use Earth as our way to scale it, and then everything else scales appropriately. So I'm going to go ahead and open up the notebook, show you what's in here. Of course, it is in the assignment below as well. I should have marked my page. Okay, so right here, it's going to show you guys, these are the model notebook pages that I have ready to go for you. And it says the astronomical unit is the mean distance between Earth and the Sun. Of course, mean is the average, which we've worked with all year long. And it is calculated as 1.50 times 10 to the 11th power meters, and that is in here as well. As I already explained, light years are what we use if we are talking distance within the galaxy and within the universe. So the materials that you guys are going to need for this, as I've already explained, if you have them, are chalk or sidewalk chalk. If you have a tape measure, that would be fantastic. If you don't, it'll be okay. Okay, and then I want you to use a post-it note, note card, or sheet of paper that you tape down to the ground that has a sun drawn on it. I'm not talking one of those crazy triangle suns, okay? We don't need that kind of confusion out there. The sun is a sphere, so let's make it a sphere, okay? And then I do encourage you to have a calculator for when you're going to actually be doing your data table, but I'm going to give you a big hint now that all you have to do is move a decimal point. So once you see the first one, bye son, love you. Once you do the first one, the other ones will be much easier to tell what the scale is, and it's pretty easy to move those decimals around. And then lastly, don't forget before you go on your walk that you need to have water with you and you need to have sunscreen on. You guys know how I feel about sunscreen. Also, of course, you need to keep distance from others while you are doing this lab. The intention is to get you outside. It is not certainly to undermine our social distancing that we're supposed to be doing, so keep that in mind as well. This is split into 2 days. So day 1, you're just setting up your notebook, you're watching this video. Day 2, actually take the walk. Of course, you need to check your weather first, make sure that you're good to go on that second day, but you don't have to do it all in one day. Day 2 is the actual chalking the walk portion of it, which all of the instructions are laid out for you here. Of course, you do need to be copying all of this into your notebooks. And then the data table, I have it right here for you. And this column right here is your space between your planets. So as you're doing your walk, this is how far spaced out you will be, and it is measured in centimeters and meters. Okay? The actual analysis questions for these will be in the space below, and you guys will send them to me, please, as a Google document. I want to talk quickly about how I'm going to be accepting work. I need you guys to pay close attention to how I'm asking you to title them so that I can query things really easily, and that'll help me keep things very organized on my front, so that I know that I have all of your work when I'm supposed to have it, and then I can find your work very quickly when I'm going to be checking it. As I stated before, this is just a check mark for this week. It's just, I want to see how you're doing. I want to see if these are being implemented well. I want to see if there are any things that I need to tweak and change and to make better for you. And I can really only do that if I have some feedback in the form of your work. So the procedures are very straightforward. If you need anything, feel free to reach out and let me know, and I'm happy to help you. And it's important that you guys watch the videos either before or right after your walk for the distance with Mark Rober, where he shows how very, very, very far apart you could make these if you had the planets actually to scale. So it will show relative size, and it also is like 8 kilometers in distance. And he measures it and shows it using a drone system. So it's good stuff. And then the other video that I have for you guys in addition to this lesson is one that shows how some really interesting guys went out to the desert and they created the solar system using scaled models and a sun that lit up, and they went over a very large distance and then attached lights to a truck and then showed the elliptical orbit. So there's a lot in that video as well. It's really interesting. It's beautifully done. I hope you enjoy it. Of course, if you have any questions, comments, or concerns, just reach out to me and I'm happy to help you. And I hope you guys enjoy walking the solar system. Bye-bye.